Kubernetes is a container orchestration technology. Put simply, that means that if we have a cluster of machines, containers that run on top of those machines are going to be controlled and coordinated by Kubernetes. Let's break this down even further. Let's first focus on the container cluster. A cluster, by definition, includes more than one machine. Those machines could be physical machines, that is bare metal. They could be virtual machines running inside an on-premise data center, or they could be cloud virtual machine instances such as Google Compute Engine or Amazon Elastic Compute instances. It doesn't really matter what the underlying infrastructure is. In any case, so this cluster, which consists of a number of different machines, is going to be broken down further by Kubernetes into a master and worker nodes, or minions as they used to be called. On top of the worker nodes are going to run pods. And this word pod is maybe the most important concept in all of Kubernetes. This is the fundamental unit, the basic atomic unit of abstraction in Kubernetes. A pod consists of one or more containers. All of the containers within a pod will share namespaces and a bunch of state information. More on that in a moment. So a pod will contain one or more containers which are tightly coupled to each other. Each of the worker nodes will have some pieces of Kubernetes software running on them. These bits of software will be in constant communication with the Kubernetes master. And that master is going to consist of various different components of Kubernetes, which are going to make sure that the containers within the pods are all running exactly as required or as desired by the Kubernetes administrator. We are going to double click on every one of these entities. We are going to have a lot more to say about the master, about the individual nodes or minions, about pods, and about the way in which the containers inside those pods actually run. But for now, just understand this high level picture, and it might also be helpful for you to relate this to a very similar architecture, that of Hadoop. If you are familiar with Hadoop, you can see that virtually all of the essential elements are the same. There is a master node, there are a bunch of workers which run compute. The master communicates with those workers using agents of various forms, and it schedules compute jobs and assigns resources within the cluster. And this is why our analogy between Java and Docker can be extended one step further. If Java is like Docker, that is a runtime abstraction, then Hadoop is like Kubernetes, an orchestration system to run a cluster of compute jobs containing containers. Just as a Hadoop cluster has to deal with node failures and various other disruptions, and just as Hadoop helps us to build distributed systems running Java, in exactly the same manner, Kubernetes helps us to build fault tolerance, scaling, quick rollback, auto healing, and a bunch of other important features in the world of containers. So Kubernetes can be thought of again as an orchestration system which provides auto healing, scaling, load balancing, and so on. Let's very quickly also talk about how a user would interact with a Kubernetes cluster. In a nutshell, this is most likely going to happen using a command line utility called kubectl, that is kubectl. Kubectl can be used in a few different modes. We'll get to those. The most common mode involves the user specifying a manifest. This is a markup file in a format like YAML or JSON, which defines the state of the system. This manifest is then submitted using kubectl to the Kubernetes cluster. The master takes responsibility of parsing that manifest and making sure that resources get allocated in order to bring the actual state of the system to match the desired state specified in the manifest. Once again, we'll have a lot more to say on this. Notice that what I just described is a pretty classic declarative programming model. In what I just described, we are not telling Kubernetes how to go about getting to the desired state. We are only telling it what the desired state is.